Okay, let's do a real example. Let's have some fun. So, most of us have probably been bumped off a plane before, right? So you show up at the airport and there's like, too many people showed up for the plane. And you think, why do they do this? Well, the reason that they sometimes have to bump is they oversell. And the reason they oversell tickets is because not everybody shows up. So if you're running an airline and you've got 400 seats, and people only show up, 90% of the time, you want to sell more than those 400 seats, right? So that your plane's pretty much full. So let's do an example. Let's suppose, to make it simple, that our plane doesn't have 400, it's got 380 seats. So let's suppose that we've got a Boeing 747 with 380 seats. Let's suppose that 90% of the time people show up. So we've gathered, we run an airline, we've gathered lots of data. We pretty much know 90% of the time people show up, and that it's independent. So one person's decision to show up doesn't have anything to do with anybody else's. Now that might be true, right? Because if it's snowy, if I'm late, you're likely to be late. But let's just suppose that these things are independent. And let's suppose that we sell 400 tickets. Now we want to try to get some understanding, like, okay, what does that mean? What's the likelihood if we sell 400 that we're going to have more than 380 people show up? Here's where the model can help us, because it'll tell us what the mean is. It'll also tell us what the standard deviation is. So the mean, right, if I sell 400 tickets and on average 90% of people show up, that means I should sell on average 360 tickets. That's less than 380 seats, so I should be fine. But what I care about, right, is more than 380 people show up. So more than 380 show up, guess what? They're going to be mad, right? Because they're going to be like, I paid for this trip to go to Florida. I want to go to Florida. I don't want to be bumped. So the 360 doesn't tell us enough. We want to know something about the distribution. Okay, well, look, we've got a formula, right? Remember, so N was 400 and P was 0.9. So P times N is 360. That's our mean. Now, the standard deviation we can solve for pretty easily. That's just the square root of P, which is 0.9, times 1 minus P, which is 1, times N, which is 400. So if we multiply that out, that's 0.9 times 0.1 times 400. 0.1 times 400 is 40, times 0.9 is 36. So that's just the square root of 36, which is 6. So 6 is our standard deviation. So now I know I've got a bell curve with a mean of 360 and a standard deviation of 6. Okay? Well, that's useful. That can help us, because let's go back and let's look. That means our mean's 360, our standard deviation is 6, so that means 68% of the time we're going to be between 354 and 366. That's great. It means that 95% of the time we'll be between 348 and 372. Also great. It means 99.75% of the time we'll be between 378 and 342. Well, how many seats did we have? We had 380 seats. So this means that 99.75, actually more than that, right? More than 99.75% of the time, we won't overbook.